Hey, welcome back. It's me, Mr. Treewin, and it's another day and another lesson in mathematics, specifically geometry. So today we're going to be looking at something called the distance formula. We're going to be figuring out the distance from one point to another point on a graph. And so I'm going to take you through a couple ways of doing this. The first way, I'm going to do more of a visual, and then I'm going to show you an actual formula. And I'm going to show you another more famous formula called Pythagorean Theorem. And I'm going to kind of demonstrate through this video how the Pythagorean Theorem and the distance formula are really the same thing. So let's take you through the first thing of what we're going to be doing here, and that is to look at this problem behind me. And it says here, a pitcher throws a ball to a batter who hits the ball to the shortstop. If the ball travels in a straight line between each, what is the total distance traveled by the ball? Round your answer to the nearest tenth of a foot. Okay, so let's start off by first marking the two spots, and then I'm going to zoom in first so we get the biggest possible view here. But we're going to hit a ball from a batter right here to the shortstop right here. So the ball is going from the batter to the shortstop. All right, well, what I'm looking to do is figure out exactly how far that is to the nearest foot that ball is going to travel. All right, so to do that, I'm going to have to take into account two things. And I'm going to go back to those last lessons I went over with midpoint and partitioning in the way that I find the two measurements. So the two measurements I'm most interested in are going to be how far I travel across and how far I travel up. So if I travel across, I always do that one first because x always comes first in just about everything to do with mathematics. So if I come across here, it's a distance of 5 units, and if I go up here, it's a distance of 10 units. But the ball doesn't go, that's if I walked all the way over to the 5 spot and then marked all the way up, I would travel a total of 15 units. But the ball is going diagonally, which means it's going to save a little bit of distance there because it's not going to be traveling the whole way because it's going to go from here to here, not all the way across. So we're going to have a smaller number. So we know that the answer, if I took the long way, would be 15 units. But again, the ball is traveling diagonally across the page, so it's not going to be quite that easy. So let's take the two numbers into account. So I traveled in one distance, I traveled across 5. So I'm going to use something called the Pythagorean Theorem. And it's kind of the famous one that everybody has ever heard of whenever you mention the word geometry. The answer is always, I don't remember anything from geometry except that whole a squared, b squared. Or you say, I don't know what geometry is. Is that the one with the a squared, b squared? Why, yes, it is. And Pythagorean theorem is a formula that's used to find the distance of the side of a triangle, more specifically a right triangle. That's what I just drew here, a right triangle. So if I use the Pythagorean theorem to do this problem, I'm going to take into account two things. Now, A and B are what you call the legs of a triangle. They form the right angle, and we call those the legs. And so if I find the distance of each leg, in this case it's 5, so I traveled a distance of 5 units across the page, and then I find the distance going up the page is 10 units, and then C is the distance from here to here. So A and B are your legs, and C is called your hypotenuse. And so I can figure out this distance if I use this formula right here. So 5 squared is 25. 10 squared, meaning 10 times 10. When I say squared, I mean 10 times 10, 100 equals C squared. So 25 plus 100 is 125. Now, back in algebra, we went over this many, many times, and we always use an inverse operation. So the inverse, for example, of adding is subtracting, multiplying is dividing. Well, if I have a square, the opposite of squaring is called a square root, or the inverse, not so much opposite, but the inverse is the square root. So I'm going to undo this square by using a square root. So the C squared will now just be C. And then when I take 125, and I do what's called the square root button here on my calculator, I get, and it says to the nearest tenth, so I'm going to only use one decimal, or 1 point after the decimal, so that's going to be 11.2. Now I rounded that up because you can see in the picture there's a whole bunch of decimals on my calculator. So I'm going to round that off, which means that this is called an approximation, so I need to use the symbol meaning approximately. Now let's take a look at this answer. Before we call this done, we're going to have to think about this for one moment. But looking at this answer, 11.2. All right, well, we were talking about feet, okay? This could be Little League, but 11 feet is not a good answer because that would be like this far. So what we're gonna do with our answer is we gotta look at this graph and say, wait a minute, it's 11.2 units, okay, 11.2 units. And then I gotta look at this graph and it says every one of these units is equal to 9 feet, which means I need to take my final answer and times it by 9. Now when I do that, I go 11.2 times 9, I get 100, oh, still an approximation now because this was a rounded answer, 100.8 feet. Now this is called the Pythagorean Theorem. Now I'm going to do this same question again, but I'm going to do this next question, I'm going to do this time I'm going to use the actual distance formula, and I'm going to show you how I got that distance formula. It comes from our textbooks, obviously we have all of our formulas in there, but I'm going to show you the distance formula. I'm going to show you how it is the same thing as what I've got right here. Okay, so I'm going to erase this for a moment, and you can see our answer was 100.8. All right, so we're going to erase this. We're going to come back this time, we're going to try doing the problem, but we're going to use the distance formula. And the distance formula looks like this. The distance between 2 points is defined as the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, well, let's see where those numbers come from. So the x and y, we talked about this the other day, was our first point and our second point. So if I'm at the first point, I'm the batter, I'm at 0, 0. And our second point is at the shortstop, and our shortstop is located at 5, 10. Remember, we labeled these the other day as our first point and our second point. So our first point was our x1 and our y1, our x2 and our y2. All right, let's see what happens when I go and follow the formula. Let's see what happens. It says x2 take away x1. So that would be 5 take away 0 squared. Now my second one is y2, 10, take away 0 squared. All right, 5 take away 0 is, or 5 minus 0 is 5 squared. 10 minus 0 is 10 squared. And these are all underneath the radical symbol or the square root symbol. So 5 squared means 25. 10 squared is 100. 25 plus 100 is 125. And guess what I'm doing again? Taking the square root. So again, when I take that square root, what did we get last time? It was 11.2. And then we had to take our answer and we had to times it by 9, giving us 100, oh, did it again, 100.8 feet. Notice I got the same exact thing both times. How could that be? They're two totally different formulas. Well, they're not in it really the two different formulas, because what did the Pythagorean theorem do when I did that one? It counted the length of the side of the triangle, which happens to be right here. It's the same thing. We just simply took, like we did in that first section of our textbook where we figured out the length of a straight line, well, we just simply counted it out. 1, 2, 3, 4, 5. And then for the other one, the other leg of Pythagorean's triangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 and 10 are the same thing. They're just the lengths. These two just represent the sides or the legs of a right triangle. And then when I take the square root, that's finding the length of this side called our hypotenuse. So we have two different ways to do this problem. If I have to do this problem, I'm going to use the way that suits the problem. For example, if you draw me or give me a picture like this, all day long I'm going to be using Pythagorean Theorem. If I just give you two sets of random numbers and no graph paper and no notebook, or no graph paper, just a piece of notebook paper, I'm going to have to go to the distance formula, or I'm going to have to draw myself a really large graph and I'm going to have to count it out, figure it out. So it all depends on the way that you want to do the problem, or it depends on how you're given the problem more specifically. Another way you can do this is to count it out, and I'm going to explain that in the next video, but this is just going to be part one of the distance formula to get you started. All right, well, I hope that was informative, and I hope you figured it out for now, and then we're going to come back and make a part two to this video. So thank you.